All right, guys, I'm going to go kind of quick, but the teacher can pause as needed. The first thing I'd like you to do is take out your Target 48 Packet 1 from Tuesday that we worked on, where we did all the graphing. Actually, I'm sorry, this was from Monday. We talked about kind of the patterns that we saw with the different types of equations in the generalized, and that ties to how we can graph these quadratic equations. All the problems in number 1 just had an ax squared term. All the problems in number 2 had an ax squared plus c, and all the problems in number 3 had all three parts of a quadratic equation, ax squared plus bx plus c. We talked about how the problems in number 1, if the a value is negative, it opens down. If the a is positive, the parabola opens up. The other thing that matters is as the absolute value of a gets bigger, the graph gets narrower. So for example, this equation isn't as narrow as this equation or this equation. These two would have the same narrowness because the absolute value of 4 and negative 4 is both 4. So then as you look to number 2, all of those equations have a plus c at the end of them. So what you hopefully noticed is the plus c shifts the graph up or down by that amount. So here we have negative x squared plus 4. The vertex here is at the point 0, 4. Here we have 1/2 x squared minus 2. So the minus 2 tells us the vertical is negative 2. If the minus 2 weren't there, the vertex would be at 0, 0. And again, you can see what the 1/2 does. It makes it a little wider. Here, the negative makes it go upside down. So for generalized number 3, the c shifts the graph up or down. Positive is up, minus is down. In those cases, c ends up being the y-intercept. And then if you look at question, or generalized 4 for questions 3, the linear term, the bx term, that's kind of complicated, and don't worry too much about that. It moves at both left and right and up and down some, and it's hard to pick out some apparent patterns there. So the next few generalized questions were about what I asked you to do for homework where you solved your 2 equations. So I did a few of those here. And I'm just going to focus on number 3e. So what I did is I took this equation and set it equal to 0 and solved it for x. There were 2 ways I could do that. The first method right here is by factoring. So I factored out a negative 1, and then I found 2 numbers that add to negative 5 and multiply to 4, and I got this. And the 2 solutions then are x equals 4 and x equals 1. The other way I could have solved that quadratic equation is I could have used the quadratic formula. A equals negative 1, b equals 5, c equals negative 4. And I can put that into the quadratic formula, which is negative b plus or minus the square root of b squared minus 4ac, all of that divided by 2a. But you'll notice my work here, I actually split them up and gave them each their own denominator. So I thought of it as negative b over 2a plus or minus the square root of b squared minus 4ac all over 2a. The reason I did that is so you could see what's going on there. When you do that, the negative b over 2a ends up becoming 5/2, which is 2.5. The square root of b squared minus 4ac all over 2a ends up being 3/2, or 1.5. So the 2.5 plus 1.5 gives you the 4. The 2.5 minus 1.5 gives you the 1. Those are your 2 solutions. But if we look at the graph in the table, we can see how there's symmetry around here. So the 2's match up, the 0's match up, negative 4, the next one here would be negative 4. And the average of those is 2.5. That's your axis of symmetry. So if you look at like these 2 points, these are the 2 answers, 1 and 4. The axis of symmetry is going to be right in the middle of those, which is a vertical line with equation x equals 2.5. So that's what we're referring to when we talk about the axis of symmetry. And the vertex is always the point on the high or low point of the parabola, and it's always on the axis of symmetry. So to kind of generalize what we were seeing there, for number 5, when you solve the equations equal to 0, the x equals, that represents the x-intercept. They're also called the roots of the equation. And then this part of the quadratic formula is the axis of symmetry. This part is how far right or left of the axis of symmetry the zeros are. But this is really the important part you're going to be working on today. All right, so if the teacher could pass out the worksheet, Target 48, Worksheet 2. And we will go through some examples of that. Again, pause.